Today we'll be learning about the first derivative test, which is section 3.3 in your textbook. Okay. So the first derivative test is used to find relative maxes and mins. And we use this by finding the first derivative. You're going to find f prime of x. Then you're going to set equal to 0, and then this is going to give you CP, which are your critical points, and then you test the values. Okay, and then when you test the values, you're going to see that if f prime of x changes from a positive to a negative, you're going to have a relative max, and this is how I remember it. So if it goes from positive to negative, you're going to go positive, up, and then negative. So that's a maximum. You have a mountain. If f prime of x changes from negative to positive, you're going to have a relative min. Now, if f prime of x doesn't change and it goes positive both ways, you don't have either a max or a min. It just continues on. Okay. So we are going to solve for the relative max and mins using the first derivative test. Now, for the problem, f of x equals 1/2 x minus sine of x on the interval 0 to 2 pi. So, move this for now. So, first, find f prime of x. So, we know that 1/2 x is just going to become 1/2. F prime of x equals 1/2. And we know that the derivative of sine x is cosine x. So we have 1/2 minus cosine x. Right? So we have the first derivative. Second, set equal to 0. So we have 1/2 minus cosine x equals 0. And this will give us our critical points. So we have negative cosine x equals 1/2. Divide by -1, so cosine x equals -1/2. And by knowing your unit circle, we know that cosine of x equals -1/2 at pi over 3 and 5 pi over 3. We know that by unit circle. So now that we have our critical points, we plug this into, I plug it into a number line. So what we're going to do is plug it in. We have pi over 3 and 5 pi over 3. And what you're trying to do when you plug in your values, you're going to plug in one less than pi over 3, between pi over 3 and 5 pi over 3, and then greater than 5 pi over 3. And this will give you whether it is positive, negative, anything like that. So when we plug in a value less than pi over 3, say pi over 4, that's going to give us a negative number, because cosine of negative pi over 4, or cosine of pi over 4 is decreasing. So this will give us negative. Then if we plug in one between pi over 3 and 5 pi over 3, say pi, we get a positive number. And then if we plug in one greater than 5 pi over 3, say 7 pi over 4, f prime is again decreasing. So now we're able to see that at pi over 3, it goes from negative to positive. And then at 5 pi over 3, it goes from positive to negative. So by the first derivative test, since pi over 3 goes from negative to positive, we have a relative minimum. And since at 5 pi over 3 it goes from positive to negative, we have a relative max. So basically you just see where the f prime function changes from negative to positive, and that will give you your relative maxes and mins. Now we can do a little harder problem. This will require a little more extensive work on the derivatives. So first we find our derivatives. So since we have to divide, we have 2fx equals x to the 4th plus 1. You know that f prime of x equals 4x to the 3rd. And g of x equals x squared. G prime of x equals 2x. So this is going to give us 4x to the 5th minus, I just use the brackets, 2x times x 4th plus 1 all over x to the 4th. So now I'm going to factor this out. We have 4x to the 5th minus 2x to the 5th plus 2x all over x to the 4th. So this is going to end up distributing to each one. So we have minus 2x to the 5th, so we're going to have 2x to the 5th minus 2x over x to the 4th. We can take out a 2x, and then we are left with x 4th minus 1 over x 4th. One of these x's will cross out. So now we can factor. We're going to have 2x squared plus 1, and then x minus 1, x plus 1, all over x to the 3rd. So this is basically just getting the derivative. So we have the derivative, and now we need to set it equal to 0. Now when we are setting it equal to 0, we're going to look at each individual piece, since these are all being multiplied by each other. If one of them is negative, then if one of them is 0, it makes the whole thing 0. So if we look at x squared plus 1, we know that we know that there's nothing there that can give us 0. So that portion of it doesn't matter. But we know if we get a 1 here, that'll give us 0, and if we get a negative 1 here, that'll give us 0. As well as if we had 0 on the bottom. However, if we have 0 at the bottom, that is where the function does not exist. It's not in the domain. But for our purposes, we use it as our test value. So we're going to use critical point at -1, 0, and 1. Okay. So we have our number line. We're going to have -1, 0, and 1. Now, remember, when you plug in your test values, you always plug it back into the derivative. So if we use -2 here, we plug in -2. We plug in these values into the derivative. So when we use -2, we get we're just going to pretend we plugged it all in, we're going to get a negative number. That's decreasing. Now, if we plug in, say, -1/2 here, it's going to be increasing. Something between 0 and 1, 1/2 again, it's going to be decreasing. And then if we plug in 2, it's going to be increasing. So we see we can't look at 0 because it does not exist, but we can look at the values at -1 and 1. And at -1 it goes from decreasing to increasing, and then at 1 it also goes from decreasing to increasing. And again, we can't look at 0 because if 0 is x, we would have a vertical asymptote. So it's not in the domain, but we use the critical points to find our test value, to use for our test intervals. So by the first derivative test, oh, and then one thing I forgot, you always have to, once we get these points, -1 and 1, we need to plug them back in to the function to get our y values. So when we plug that back in, we're going to get -1 and 2 and 1 and 2 are relative minimums because they go from negative to positive. So that is the first derivative test. You always find your derivative, set it equal to 0, find your critical points, and you know your critical points are where the derivative is 0 or does not exist. So in this case, -1 and 1 are where it's 0, and 0 is where it does not exist. Then you find the test values in the intervals, and then you see where it goes from negative to positive, so it's a minimum, and positive to negative, where it's a maximum. So that's the first derivative test.